the start broadcast button. Sooner or later, it's going to say that this hangout on there is live. And so on the 26th of this month, which is April, I was invited to give a talk at the South Florida Test Automation User Group on property-based testing. It's been like, I think a year and a half since I think I'm more confident, like a year and a half since I've written about property-based testing or did a podcast about property-based testing. And so I had to like revisit it. And I was pretty impressed with some of the blog posts that I wrote. I was detailed enough that things kind of like made sense to me. Things kind of clicked with me. It's amazing how like you can leverage your blog posts and really appreciate the time and detail that you put into the content to help you at a later date. I got a big head, man. I got a large brain, but things still leak out of it, you know? So I'm putting up this video because I need to practice talking in front of people. It's easy for me to talk to myself or think out loud, right? But like to basically train my subconscious so that when I get up on the podium or on the platform at the podium, that I could just go into like autopilot and I could just talk. And like, I don't really have to think. It's more of a conversation that I have with an audience that, well, they just don't talk back. And so I'm probably going to do like maybe 2 or 3 videos, maybe 4 or 5, I don't know. So I can keep revisiting certain sections that I want to touch on. And hopefully when I discuss property-based testing at this South Florida Test Automation User Group or meetup, I think it's South Florida Test Automation Meetup, things just flow and things just connect. So that's my objective. So okay, so let me start over. How would I want to start this? Well, I'll probably share my screen. Come here, Willis. Share my screen, present to everyone. Yes. And I would probably say, all right, I'm sharing my screen. And well, if people don't know what property-based testing is, what could I do to pique their interest? What caveats should I mention to make them like, sit back and take note, right? So I would probably say, I love functional programming. It's like, I don't know, it's like a resurrection, it's like a new birth. It's something that reinvigorates me. It's this whole functional programming, this new, I'm not sure if it's fair to say new paradigm, but this alternative paradigm of solving problems via code. I like it because it took me probably maybe 8 months for things to click. And if it takes me 8 months for something to click, then chances are that other people may be struggling and they probably give up, which means that I deem myself more competitive and I know more about certain things than other people, which creates a belief system that I'm more valuable than those people because, well, I'm Scott Nimrod and I'm very competitive. And well, I have this whole notion of the United States of America. People like me have to go above and beyond to have the same opportunities. And thus, this whole functional programming sets me apart from my competition. and it will pretty much supports the whole notion or my belief system that, well, you have to be undeniable. All right, cool. So that's probably too much. I probably shouldn't share all that at that user group. All right. So if I go back and I say, I love functional programming. It's like an alternative paradigm to solving problems via code. Okay, so that might sound good. Okay, good. Then I could follow that up with, in addition to this whole paradigm shift that we call functional programming, it has its own ecosystem, right? So there's object-oriented programming, C sharp, Java, Ruby, and I'm sure other languages, and they have their own ecosystem, right? But did you know that in functional programming, there's an ecosystem to it as well? Well, I say ecosystem. What what really is an ecosystem, right? And maybe I'll ask the audience, that question that's not rhetorical, and maybe someone will tell me what it is. And then I'll follow up after the response and say, you know, Webster's dictionary defines an ecosystem as, and I don't know, this is my first time looking it up, ecosystem. Probably just one word, right? Ecosystem, I don't know, definition. And I would probably say a biological community of interacting organisms in their physical environment. All right. And so I will probably take this definition and I will probably cross out biological. I'll probably keep organisms, but it depends. Like, what's the definition of organism? Come here. An individual animal, plant, or single cell life form. Okay. Well, programs, they kind of represent a life form. There's decisions that they follow. There's decisions and there's states that reflect those decisions. It seems like life to me on the streets. Anyway, let's bring it back. Let's bring it back. So yeah, I would probably say like, oh, I love functional programming. Did you know functional programming has its own ecosystem that just like object-oriented programming has its own ecosystem, right? And then I would probably say, in object-oriented programming, the ecosystem in object-oriented programming is you have what would I say? What would I say? You have, test automation, and you have you could say WPF, or you could say frameworks, right? And what else does a ecosystem have in code? Um, oh yeah, you have object relational mappers, object relational mappers. And can I have a fourth example? I said test automation. Uh, I should say test automation frameworks, or I could just say frameworks, and then I could say example, and I could say like you know test automation. Then I could say like UI. Oh yeah, UI. Then you could say data data store frameworks such as object relational mappers and what else? That might be fine. Oh, I wanted to say like SQLite. SQLite can rely on entity framework. No, I don't know. That might be. keep it simple. So I could say, you know, ecosystem, some examples of some of these technologies that can participate in the ecosystem are frameworks such as test automation frameworks, UI frameworks. And, you know, if you say test automation, then, you know, you probably got to have an example of like in unit, you know, um, X unit and MS test, you know. And for UI, you probably can say, oh, come here, Willis. For UI, you can probably say, you know, WPF or, you know, Xamarin, say Xamarin Forms, maybe. Okay. Data store, you have like object relational mappers, or you could say, I'm not sure I want to say that. You could say entity framework. And you can say, well, that is object relational mapper. You could say SQLite. Um, so you could say stuff like that, right? And this UI should probably be back here. Actually, this whole thing should probably be back here. And so let's start over again. I could say, you know, I love functional programming. And then I will follow it up with, you know, very similar to object oriented programming, functional programming has an ecosystem too. And what do I mean by ecosystem? Who can tell me what an ecosystem is? And someone raises their hands and they tell me what an ecosystem is. And I then Google the definition of an ecosystem, and which says that it's, you know, a collection of living organisms that belong to some, I don't know, what was that again? Ecosystem definition. This is good to do again. A community of interacting organisms and their physical environment. Okay, so I read off that definition, and then I say, well, what would be an example of an ecosystem in .NET, specifically related to C sharp? And, you know, no, I would back that up. I would say, I would read off the definition of ecosystem that I Googled, a community of interacting organisms and their physical environment. And then I would probably say, and this might end up being like a PowerPoint presentation, because then I would say, well, what could belong to a ecosystem? And I would say, you know, I would say something like perhaps frameworks, right? Frameworks. And then I would say, what else besides frameworks could belong to an ecosystem? I would say perhaps a data store, right? Something like that. And then I say, can anybody else tell me an example of something else that can belong to an ecosystem based on this context of object-oriented programming? And then they would probably say, what was the last one I had? Frameworks, data store, like test automated. No, test automation was under frameworks. I forgot what the last one was. Hold up, let me go over here. UI. Oh, yeah. So UI is actually under frameworks, data store. It would be test automation, right? So I'll probably have these like 3 bullets. So let's start over. I'll say, oh, I love, you know, functional programming. Did you know functional programming? They have ecosystems just like object-oriented programming does, right? Relative to the programming language. Did you know that? But you know, what do I really mean by ecosystem? Who knows what an ecosystem is? And then someone raises their hand and they say what an ecosystem is. And I take them to the definition that I Google and I say ecosystem is a community of interacting organisms in their physical environments. And then I say, so what would be within programming or specifically the context of object-oriented programming, what are some examples of technologies that would make up an ecosystem. And, people will probably say frameworks, and then they would say, data store, and then they could also say test automation. And for frameworks, you could say, actually, test automation would be under a framework, but it would really be like, I'll just leave the abstract like that. Okay. So anyway, I think I beat a dead horse right there. And so I would tell them, well, what are some examples of the C# ecosystem? Um, Hence, C# is object-oriented programming. And so then they could probably say, well, for frameworks, you would have WPF, Xamarin, right? And these are all UI frameworks. Um, there's other frameworks, I'm sure, that are not UI related, such as under test automation, you have NUnit and XUnit. Okay. For data store, you have come here. For data store, you have entity framework, and you have SQLite. All right. So I could go ahead and do that. Repetition, repetition, repetition. Okay. So ecosystem, frameworks, data store, test automation, right? But frameworks, I should probably do UI, right? Because test automation is a framework, so I should make it more granular. So basically say, where are some examples of some ecosystems? I could say UI frameworks, maybe like that. And then test automation frameworks, something like that. Okay. And then I say data store, right? And so these are some examples of technologies that belong to a object-oriented ecosystem. Okay. So I would do that. And I'll say, well, in functional programming, there's ecosystems as well. And some of these technologies that belong to an object-oriented programming ecosystem can also be shared or leveraged by functional programming ecosystem. Specifically, we're talking about, within the context of .NET. And so, C# is like the 800-pound gorilla in .NET is the chosen one. And so, this WPF, Xamarin, Entity Framework, SQLite, NUnit, XUnit, with emphasis on NUnits, these all belong to the C# ecosystem of delivering solutions, solving problems, right? And so I could say, but that within object orientation, there's some limitations. Believe it or not, within functional programming, not only can we leverage all of these technologies that C# or object orientation can take advantage of within .NET, but we can get even more, okay, naturally. And then and then I could probably follow up by saying, what if I told you that, no, let me start over. I would say, for example, how many testers are in the room? And I mean, and obviously this is South Florida Test Automation Meetup, right? So everybody should raise their hand except for recruiters and maybe managers or whatever. So I would ask a question like, for example, how many of you in this room are testers? And like maybe 80%, 90% of the hands go up. Okay. And I would say, okay, so how many of you are also programmers? Okay. Well, this is the test automation user group, right? South Florida Test Automation Meetup, right? So there should still be a substantial number of people that raise their hands when I ask how many of them are programmers, right? Now, if I say SDET, that might scare them because they're not West Coast, I don't think. And I mean, honestly, no disrespect to Florida, but like, Florida's not Wall Street. Florida's not Silicon Valley. They may be in another, I don't know, 15 years, but they're not right now. So I can't scare them with like crazy acronyms like SDET, Software Development Engineering Test. I don't want to do that. I'll just say, how many of you guys are programmers? And so a substantial number should probably raise their hand. And I'll say, okay, cool. So who knows what a unit test is? Or no. I will say, so if you're a programmer and you're a tester and your job consists of you writing code that qualifies the quality of software. I probably could say that differently. How many of you write a unit test, right? And so some hands would go up, and I would say, what really is a unit test, right? And someone raised their hand and say, it's when you test a unit of code in isolation, right? And I would say, okay, so what does that really mean? And some other hands will go up and they will tell me a hardcore definition of what a unit test is. But there's different schools of unit testing. But I won't really dig into that with them. But I would say, okay, cool. So, at a high level, the definition of a unit test is, I don't know, testing code in isolation or testing a unit code in isolation. So, what would be an example of a unit test if we wanted to add two numbers? And so, hopefully, we would write some pseudocode and they would guide me to say that, you know, um, 2 plus 3 equals 5. And they would go through the steps of setup, test, verification, cleanup, or the triple A's of arrange, act, assert. All right. I don't like the triple A's. No, it doesn't really click with me. But every test has a setup, every test has a test, every test has a verification, and every test has a tear down, which could be implicit because we rely on garbage collection within .NET. Okay. So I say that. Okay. And so they walk me through writing a unit test via pseudocode, most likely of 2 plus 3 equals 5. Okay. And this is where I get them. All right. So then I would say, all right, cool. So let's look at this test that we just wrote. What do we see with this test? And people will probably look at me like I'm crazy because that's a very like general, ambiguous question. And they would probably say, well, what do you mean? And I'll say, okay, well, if you look at this test, we're specifying specific inputs. We're specifying that the operands are 2, 3, and that when we add them together, we're specifying a specific output that they should basically result in, which is 5. So translated, we are stating specific inputs and a specific output. Okay. And they would say, well, duh. And then I would follow up with, well, with that said, what we probably have not considered is that in general, the automated tests that we write, whether they're unit tests or integration tests, what we're really doing is we are writing example-based tests. In an example-based test, we are specifying examples of what we expect to work and what we expect to not work. We're specifying examples. We are specifying that we need a 2, we need a 3 as inputs, and as output, we must have a 5, right? Examples. All right, so this is where people should start, sitting up in their seat and scratching their goatees, right? And they say, okay. And then I will follow up with this. I will say, what if I told you that these examples, they're good to have, I think. They're useful. But don't we also have to take into consideration edge cases? I mean, okay, well, what are you talking about, Willis? Well, okay. Who can tell me what an edge case is? Right? I would ask that question. And so, I would ask that question, and someone would tell me what they think an edge case is. And I say, well, let's look at the dictionary term of an edge case, right? And I will reference Wikipedia, perhaps. An edge case is a problem or situation that occurs only at an extreme, maximum or minimum operating parameter. For example, a stereo speaker might noticeably distort audio when played at maximum volume, even in the absence of any other extreme setting or condition. An edge case can be expected or unexpected. In engineering, the process of planning for and gracefully addressing edge cases can be a significant task, and yet this task may be overlooked or underestimated. And I want to draw attention to overlooked or underestimated. Okay. So when we think about an edge case, we should immediately think about a test that is overlooked or underestimated. Okay. And then I'll follow up with no trivial edge cases can result in the failure of an object that is being engineered. They may not have been foreseen during the design phase, and they may not have been thought possible during normal use of the object. Very good. For this reason, attempts to formalize good engineering standards often include information about edge cases. Yes. All right. Good stuff. So now my audience, they have been familiarized, for lack of a better term, with the definition via Wikipedia of an edge case. Okay. So then I would say, so let's go back to what I was talking about, unit tests, and how, well, the way we've been writing unit tests, what we've really been writing are example-based tests. Well, what would be an example of an edge case? And people will probably look at me and they'll probably scratch their head and they say, what do you mean? I'll just saying in general, like, okay, let's talk about a different type of test, or let's talk about a different test. Like the previous test example I gave was adding numbers. What if we had a test for division? You supply 2 numbers as inputs and you have an expected output. So for example, 10 divided by 2 is 5. Okay. 100 divided by 10 is 10. Okay. I think that's right. I never really like excelled in math, but so who can think of some edge cases or an edge case if we were to write a, a test for division? And so surely someone would say, divide by 0. And I'm like, all right, good stuff. Why? Because it's undefined. You will get an exception, right? And that's an example of, um, well, this deals with like total functions, but this is an example of like pure business logic that doesn't deal with IO, but yet can still throw an exception, right? Good stuff. So I would say, okay, so we're talking about like simple math here, right? Adding some numbers together, dividing some numbers. And we also identified an example of an edge case when dividing some numbers. Now, this stuff may be trivial, but what about a business domain? There can be, well, developers are lazy in general, right? The exceptional ones, they're disciplined and they care. But I would say, in a project with mature developers that are rock stars, they really get it. They understand quality, or what goes into quality at least. You can have hundreds or thousands of unit tests, right? I'm not sure if it's Visual Studio or Azure where they have like 50,000 unit tests. But what I'm trying to say is when you deal with a business domain, well, things can become complicated. There can be, well, really policies that require testing. And you have your happy path, you have your sad path, but you also have edge cases that you should probably consider. Okay. Now, I'm not going to speak of any specific business domain examples, but I'm sure that you've had to deal with edge cases for whatever business that you've been helping. And well, how do you write those edge cases? That's kind of like an abstract, maybe even rhetorical question. And so people in the audience may like sit back and they say, who cares what they say? They'll give some answer or some response. It may not be an answer. They'll give some response of how they would write an edge case. And it's probably something I'll learn from, right? And I'll say, okay, good stuff. So the example that you told me of an edge case, would that also fit into an example-based test where you're specifying specific inputs and a specific output? And more likely, they would nod their head, say, yes, yeah. What else is there? Of course, it's going to be example-based tests. Duh. They'll look at me like I'm weird. People do that. And I'll say, okay. And then this is where I pull it out, right? This is where, like, I've been holding my spade, and now I'm about to slap it on the table. And I will say, hey, what if I told you that in functional programming, and which reminds me, I probably need to, before I even get to this point, provide a definition of what object-oriented programming is and what functional programming is. I need to insert that probably early. All right. And then probably mention object-oriented programming versus functional programming a couple times so it's still sitting in their head. All right. So that's something I need to do. And so let's imagine that I discuss, what the definition of object-oriented programming and the definition of functional programming. And so then at this point later, when I ask them about edge cases and then say and ask them for an example of an edge case, and then they give me an example of an edge case, whatever, uh, I would say, well, that's still an example based test, this edge case that we're talking about. And they will say, oh yeah, duh, of course. What else is there? And then I would say this, all right, this is where I pull out my spade. And I would say, what if I told you that in functional programming, which is different from object-oriented programming, this functional programming is really cool, man. What if I told you that all you need to do is state your assumptions about a function? You state your assumptions about a function. You state that whatever I provide as input to this function will always provide this property of an output. And then someone would say, well, can you give us an example? I'm like, okay. What if I told you that, let's assume that an assumption is when you add two numbers, the product of those two numbers will always be greater than each of the inputs that you added or each of the operands that you provided. That's an assumption. And some smart people will say, no, it's not. That's not true. Right. But anyway, that would be an assumption. And so, but there's something I'm missing. Before I say that, I would say somehow I need to wire up assumptions to auto generation of edge cases, right? So I would say, let's go back to functional programming. I would say, what if I told you that in functional programming, you don't have to create example-based tests for edge cases? What if I told you that in functional programming, your edge cases are automatically generated for you based on assumptions that you specify? I shouldn't use specify, that gets too detailed. Start over. I'll say, what if I told you that in functional programming, edge cases are generated for you based on your assumptions about a function? And people will look, yeah, I like that better. And so people would probably say, you say that again? And I would say it again. I repeat, what if I told you that in functional programming, edge cases are generated for you automatically based on the assumptions that you provide about a given function? Okay. So I say it maybe 2 or 3 times. What if I told you that in functional programming, your edge cases are automatically generated for you based on your assumptions of a function? Great. Then they would ask for an example, and I would say, okay, so an example. Let's assume that when you add two numbers, the product of those two numbers will always be greater than each of the numbers that you provided. That's an assumption, right? And then, some smart people will say, well, that's not true. And I'll say, that's okay. It's an assumption, right? And then I would introduce F#, property-based testing. All right. And so somehow I got to pull this back into an ecosystem, right? Because I opened up the talk with ecosystem. So I would say, in F#, F# shares the same ecosystem or I should say F sharp can share the same ecosystem as C sharp. But in addition to that, F sharp also has its own ecosystem. That's more idiomatic to functional programming, right? And so I could say that. And then I would say, specific to test automation, and then I would say, we have this notion of property-based testing in which we are testing the properties of functions, right? And maybe I'm not going to really talk like that, but I like to entertain myself. Um, and so I would probably say, there's N unit and X unit, but in the example that I'm going to discuss, there's going to be X unit and FS unit, like that, okay? And the example that I'm going to provide is we're going to maybe write a test for adding numbers, and we're probably going to write a test for multiplying numbers. And we're going to state our assumptions, right? I'm going to say it like that. No, I'm not. But I'm going to say it, just not in that tone. And so this is where I start engaging the group. Actually, I've been engaging them the whole time, okay? So then I say, let's write some code. And from there, I would say in .NET, you need to import some packages, right? Now, if I do Control-Alt-L, that brings up Solution Explorer. And so I would go through the motions, and I would tell them that you need to add the following packages. And I would say you need to add X unit. Actually, let me start over. You need to add FS unit dot X unit. You need to add that. Okay. Now, I thought I already added this. I think it's already added. If I go to install it, no, I don't have anything installed on here. Really? Hold up. I know I do. Hold up. Oh, yeah, yeah, yeah. Okay. I got to get rid of that. So, yeah, I got FS check. No. It's called FS check, not FS unit. Okay, good stuff. So, I would tell them that they need to import some packages, FS check, which is a derivative, if that's the right term, of quick check, which is used in the Haskell community. And so there's a fscheck.in unit, and there's a fscheck.x unit. So I'll probably tell them to do fscheck.x unit, install that. Then I will also tell them to install x unit.visual studio. X unit.runner.visual studio. Is that it? Yeah, I'll tell them to install this x unit.runner.visual studio. And this is the package that you need to install so that your property-based tests are discoverable so that you can execute them, right? When I say discoverable, like they're discoverable in here, okay? So I'll tell them to install fscheck and then xunit.runner.visual studio, okay? And so then in here, I would say, well, let's import fscheck. And I would say, let's import X unit like that. X unit dot. Oh, I should just be able to say open X unit. Hold up. Did I get a squiggly on this one on fscheck? No. fscheck dot X unit. Okay. Maybe that's it. I don't know. Anyway, so then I would probably try to create a attribute called, I think it's called property. like that. And then I would do adding two numbers results in how would I say this? I would say product. I would say product of adding two. I don't know if you call it operands. Oh, God damn it. Product of adding two. Product of adding two numbers will always be greater than each input. So product of adding two inputs, product of adding two inputs will always adding two operands will always be greater than each operand. Something like that. I'm not sure if I'm using it right. Okay. And so that's our, oh yeah, I gotta say let in here. So that's our test. Now, this property has like a, how do you do this? Is it like quiet on success equals true? Can I do that? Okay. And also, I feel like I'm missing something. By default, your max test equals 100. So I'm not going to put that in there yet. And so over here, product of adding two operands will always be greater than each operand. I could word this differently, but whatever. So then when I write the code, I basically want to create, okay, so then this is where I tell the audience that in property-based testing, we again, we provide assumptions about a function. But when we do this, in regards to the implementation details, what we really want to do is we first need to, how do I do this? I say, in property-based testing, we provide assumptions about a function, and that assumption is tested, okay? In order for that assumption to be tested, data must be generated, okay? So in property-based testing, what really happens when we test assumptions is we rely on the framework to auto-generate inputs for us. This is completely different from example-based testing. Remember, in example-based testing, you, the programmer, are specifying the specific inputs and the specific output, and you're testing that output. You're asserting that output, right? This is completely different in functional programming. In functional programming, we are basically we're providing our assumption via code, and we're relying on the framework to auto-generate inputs for us. In this case, it's going to find edge cases that contradict our assumptions about a function. Okay, good. So I plant that seed. So what I mean by auto generate, well, in order for auto generate to work, we need to create a generator. So in this case, we're adding two numbers, right? And so in these two numbers specifically, we can say they're going to be integers. And so we want to generate integers. In order to generate integers, we can do the following. We can create a integer generator. And the way that we can do that is we can say let generator equal, and then ARB, which is arbitrary dot generate. And then within angle brackets, we could specify the data type that we want, which will be int. Okay. Now with this generator, we can then say um, generator dot, how do I do this? Not generator dot, I'm tripping. Say ARB dot from gen and generator. Yeah, I could just generator. And then I could say prop dot for all, something like that. And hold up, I'm missing something. Something like that. Prop dot for all. And then I could create a function that for right now is just going to be true. And well, that other function, something like that, and then true. And so this stuff still compiles. Control Shift B. Okay. So from there, we don't really need to declare a value called generator. We can just take the generator that we generated and we can pipe that into this ARB from gen like that, and then say prop for all. Now with this function, this ARB.generate int, well, that's going to generate an int value. Notice that it doesn't generate int values, and we need int values because we need two operands, okay? So what we probably should do is in order to get that, how can we do this? I could probably go back and say let generator equals ARB.generate, and then I could say I think it's gen.map 2 because we need two operands. And how does this work? I think how does this work? Do I say fun x y goes to, and I say it's gonna be a tuple called x y. Is that how it goes? And then from there, how does this work? Gen.map to xy equals boom, boom, boom. And then I did this quickly over here. Oh, yeah. So I need this generator here, and I think I go something like that. But that's not working either. Map the given function over values to a function over generators of those values. Gen.map to. Okay, I'll get rid of the. No, I think I was right. And ARB dot from gen and then prop dot for all. Oh, no, I know what I'm doing right. Okay. So, yeah, I'm trying to do all this from memory. So we have generator, shoot, generator, stop, generator, and we are going to pipe that into our gen.map2 like that. And then we can move this over here like that. And then in this expression, we can say that this is going to be A, B is a tuple. And then we could say A plus B is, let me wrap this in parentheses. The product of A and B is greater than A, and the product of A and B is greater than B, something like that. And maybe I need to wrap this in parentheses for it to be a tuple. So what is this saying? All right, if we look at the test title, we say product of adding two operands will always be greater than each operand. That's our assumption, okay? And so we create a generator that's going to generate ints, and we need two values, right? Because we have two operands that we're going to pass in for our addition. And this is our addition right here that we're doing. Same thing over here, right? And so we need two generated values. And so we take the generator that we created, and we create a tuple of two generators. Those two generators are going to generate a value each. This generator generates this X value. This generator generates this Y value. And we're going to take that X value and that Y value, and we're going to map it to a tuple of X, Y. From there, we're going to pipe that into our arbitrary.from generator, and then pipe that into our prop.forAll. That's going to actually give us our individual values from the generator, which is in the form of a tuple. And we're going to basically decompose that tuple and take each component or each number from that tuple, and we're going to add that number to the other number, and basically make the assumption that the product of these two numbers is always going to be greater than one of the operands involved, or any of the operands involved. And we do the same thing here. So like we have A plus B is greater than A, and we have A plus B is greater than B. Okay. And that's pretty much it. Now, if I can go ahead and run this, let me see what happens. And gee willikers, our test failed. And so it says that falsifiable after one test, 0 shrinks. And it says that our product of adding two operands will always be greater than each operand is a false assumption. And here is an example. Here is a case. So remember when I said that in property-based testing, it's different from example-based testing, because property-based testing, one, will auto-generate inputs for you. And if it auto-generates inputs for you for a given function, then that means that it will auto-generate edge cases as well. And this is the edge case that falsifies. This product of adding two operands will always be greater than each operand. Hence, 0, 2 are the two operands that if you pass it into this function for adding numbers, a plus b is always greater than a, and a plus b is always greater than b. Well, this is false because 0 plus 2 is not greater than, how do I say this? 0 plus 2 is going to be 2, and that's going to be greater than a, which is 0. But 0 plus 2, which is 2, is not greater than b, which is 2. Hence, 2 is not greater than 2. So this is the edge case right over here, that 0 and 2 is the edge case that falsifies our assumption of adding two operands in which the product will be greater than each operand. Okay, so that is an example. Okay, and so how would you resolve that? Well, no, this is a test, so your assumption is wrong. So that's an example of property-based testing doing addition. Now, what else could we do? We could we can say, let's start over. Let's get rid of this, and let's say that, let's do multiplication. We can say multiplying two numbers will, multiplying two numbers is greater than adding two numbers. Okay. Multiplying two numbers is greater than adding two numbers. Okay. So how can we do that? Well, from the last example, remember that we're pretty much going to use very similar code. We're going to, again, create a generator. That generator equals arb.generate or arbitrary.generate. And we're going to use int, okay? And a generator, we're going to take that generator, but we need two values, remember, because we're multiplying two numbers, and, well, yeah. So we're going to take that, and we are going to pipe that into a gen.map 2, and it's going to be x, y, and we're going to, I'm doing this wrong, say 1, x, y, and we're going to make that into a tuple, like that, okay? And then we say arb.from gen, and we then say prop dot for all, come here, Willis, for all, and this is where we have our tuple of a b. This probably should be a fun a b, and we're basically going to say a times b is greater than a plus b, something like that. And what am I doing wrong here? That should work. What am I doing wrong here? A times b is greater than a plus b. It says function takes too many arguments. Oh, yeah. Because I need the backwards pipe operator. Okay. So multiplying two numbers is greater than adding two numbers. That's the assumption that we have. We have our generator, and you could theoretically you could do the same thing like this. You could probably do this right here. It depends on what you want. And so we have generate int, and then we map the two generators to we map the values from those generators to a tuple. Then we call arb.fromGen, and then we say prop.for all, and this is the expression that we are providing as our assumption that a times b is greater than a plus b. So what happens when we run that? When we run that, it fails again, and we see that it's falsifiable, and it provides the example of 2 and -2. So what does that mean? Well, 2 and -2, 2 times -2 is -4. And so -4 is greater than 2 plus -2, which would be 0. -4 is greater than 0? No, -4 is less than 0. So this is an edge case, again, that is flushed out via property-based testing about the assumption that multiplying two numbers is greater than adding two numbers, okay? So what can we do about that? Well, somewhere in here, I think there's a filter. I think there's a filter that we could use. I haven't done this in a while. Where is it like gen dot? How do you do this? Gen dot. I don't know how to do this. How do I do a filter on here? Is it ARB dot filter? No. It should be a gen dot filter. Gen. But filter is not showing up in here. I got to figure out how to do this. So fs check filter. And there's an ARB dot filter in here. Can I do this in here? ARB dot. I don't see filter in here either. All right, I need to find an example. But anyway, what I wanted to say is once I figure out how to make an exception and filter out twos and -2, then I'm going to run it and I'm going to see if, with the exception of 2 and -2, if this assumption is still true. And in order to do that, I'm almost positive I have a blog post on this. Bismonger property-based testing. And I'm gonna go to my blog post. Okay, I don't see anything about property-based. I don't know, why did it take me there? Generator. gen.filter. Yeah. So apparently I was right, but it didn't show up in IntelliSense. After your arb.generate, you have to do a gen.filter right under it. So theoretically, I should be able to do something like gen.filter, which doesn't show up in my IntelliSense, and I should be able to say fun, and then x goes to x. Is it not equal to 2? And x not equal to -2, something like that. So I added a filter to my generator so that it doesn't use 2 or -2. And so when multiplying two numbers is greater than adding two numbers, should equal true. This is the exception that I provided so that it filters out the values that don't support that assumption. And so I wonder if there's a better way for me to format this. I don't know, maybe not. It's probably better off this way. When I run this, let's see if it passes or not. And it doesn't pass. It uses 0 and 4. So it's saying that 0 plus 4, or should I say 0 times 4, which is going to be 0, is saying that that's not greater than 0 plus 4, which is 4. So that's another exception. So then I could say, I could add to my filter maybe x not equal 0. And I could probably say x not equal to 2. No, I'm gonna keep it like this. So what I'm doing is I'm filtering out zeros because anything multiplied by 0 is going to be 0, right? And so again, I'm finding these edge cases that basically contradict my assumption. And so now it's saying 3 -1. Well, 3 times -1 is 3. Or I'm sorry, 3 times -1 is -3. And 3 plus -1 is 2. And so this is false when multiplying two numbers is greater than adding two numbers. So now I want to get rid of negatives. Well, to get rid of a negative, one way to do that is to use the absolute value. So what I really want to say is multiplying two numbers is greater than adding two numbers. I could say I could say the absolute value from multiplying two numbers is greater than adding two numbers. I could say that as a caveat. And so I could then say, I think it's like math dot absolute like that. Can I do something like that? It doesn't know what absolute is. Can I open system? Cool. My OCD is taking over. It's open system must go before everything else. Yes. And so math.absolute of a times b is going to be greater than a plus b. And if I run that, it fails again. And so it's saying another edge case of 1 and 1. Well, 1 times 1 is 1, 1 plus 1 is 2. So again, we have this issue, okay? And so I can add another filter on here and say, okay, so is x not equal 1? And if I run that, everything is green, okay? So the absolute value from multiplying two numbers is greater than adding two numbers. It's true only if we're not using 2 or -2, or 2 and -2. We're not using 0, and we're not using 1. Then this is true. The question is this true? By default, these property tests are executing 100 different data sets. And so there's an argument that we can add. I think it's called max test equals, by default, it's 100. What is this called? How do you do this? Property, it should be max test. Okay. By default, it's 100, which means that it's already implicit. But if we want to make it 1,000, will it find new edge cases? So we do run all, and we'll see. And everything's still green. And what about 10,000? Will it do that? And everything's green. And so if we do 100,000, maybe we can be fairly confident that we have covered all the exceptions to our assumption and everything is green. F sharp is pretty cool because you can use underscores to basically signify commas. So this is a lot clearer, 100,000. And yeah, there's something else I want to try. Should be like let run 100K, something like that, equals, and then you say inherit, and then I think it's inherit property attribute. I'm not sure how this works. Inherit property, da, 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 da. Unexpected. How do I do this? In F sharp. Inheritance. Inherit, boom, boom. Yeah, I don't really know. Unexpected, boom, 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 boom. Oh, it's type. Shoot. So I'm saying run 100,000 times. So theoretically, I should be able to do this right here. Run 100,000 times. And I could kind of create different attributes that represent different configurations. So, hold on. This was crap. This was 100,000. So this was that was 100K. And then over here, this is 10,000 that I wanted, like that. So I could pretty much assign an attribute that's going to reflect a different configuration of the number of times that I want, or the amount of data that I want generated, or the amount of cases that I want generated, or the amount of data inputs that I want generated. So I could say 100,000 data inputs that I want generated for this property-based test right here. Or I could say 10,000 cases of data being generated. So that's pretty much it. All right. So this is me doing or practicing how I would deliver a talk to the South Florida test automation meetup. And at a high level, I think I understand the flow. I'm probably going to practice this probably another 3 times so that things become more congruent and I don't have to Google how to, I don't have to Google syntax to how to do things. So that's the goal. What I take from this is when you want to filter out exceptions, after you call arbitrary.generate, you can then do generate.filter. For whatever reason, that gen.filter isn't showing up in IntelliSense, which makes me think that maybe it's an extension method or something, IDK. But I think this is good stuff. I think it's productive. And the whole point of this is for me to go into autopilot mode when I deliver my sermon to this South Florida test automation meetup. So that's it. I'm Scott Nimrod. I'm available for hire. I am a .NET zealot. C#, which I'm good at, but I'm not excited about it, you know. I'm really trying to establish myself as the technical authority of Florida in F#. And so I do mobile development, particularly with using Xamarin as my tool set. And I do desktop application development using Windows Presentation Foundation. I know a lot about test automation at the developer level, hence unit tests, integration tests, and strategies to take into consideration when doing that. Test is software. Test should be treated as software. And I'm available for hire. So yeah, I am out. Adios. Te veo a ratito. Yeah.